The latest SpaceX launch did not go as planned after a promising start to what Elon Musk's company considers a new generation of a Starship spacecraft.
The Starship Flight 7 was the most advanced spacecraft in SpaceX's Starship series, yet it ended in disaster. After weeks of speculation, Elon Musk finally confirmed the cause of the catastrophic explosion, an oxygen leak. This setback has delayed his goal of making the Starship operational by year's end, and has sparked numerous questions. What led to this failure, and how will SpaceX recover? Join us as we uncover the full story behind one of the most devastating rocket explosions in private space exploration history, the destruction of SpaceX Starship Flight 7. Starship Flight 7 was expected to be a major leap forward for SpaceX and the private space exploration industry. Equipped with the latest upgrades, an improved design, and high expectations from both engineers and the public, it aimed to set a new milestone. However, instead of progress, the mission turned into a major setback when its mothership, Ship 33, exploded mid-flight. The cause? A significant oxygen leak, one large enough to raise pressure beyond safe limits. This triggered a chain reaction, resulting in what SpaceX terms a rapid, unscheduled disassembly, essentially a catastrophic explosion. The event left spectators around the world in shock. You see, everything had been going well. The launch was smooth, the Super Heavy separated without issue. And then nothing. Telemetry froze. There were no new altitude updates, no live video. And just like that, space's most advanced Starship was gone. But what if we told you that we now have a better picture of the catastrophic loss of the spaceship? Keep watching for the shocking details. Let's return to the first signs of trouble during the launch to understand better what happened. Everything looked normal for the first few minutes. For those who observed closely, Starship was soaring, reaching a peak altitude of 146 kilometers or 91 miles, well into space. The speed was over 13,000 miles per hour. The mission had successfully passed Max Q, the point of maximum aerodynamic stress. Super Heavy had completed its role and was already on its way back for landing. But something was off. In previous missions, SpaceX's camera feeds typically switched during flight phase transitions. This time, however, after Super Heavy separated, there was no new footage of Starship. No visuals of its engines igniting in orbit, nor any onboard views of Earth below. Then, the telemetry data froze, altitude and speed readings stopped updating precisely at T+8 minutes and 26 seconds. It was then that everyone at the ground control station realized Starship 33 wasn't coming back. What went wrong? SpaceX finally confirmed what many experts had feared. Starship 33 had been destroyed. But the real question was why. According to Elon Musk, preliminary findings suggest an oxygen leak in the cavity above the engine firewall. For those unfamiliar with rocket engines, let's break it down. Something had to give when oxygen leaks become large enough to cause pressure to build above the system's venting capacity. And in a spacecraft, when one part fails under extreme conditions, it can take everything down. Looking at the footage before separation, you can already see some clues. Observers noticed flames near the aft flap joint, the large control surface at the back of Starship. There was also visible damage to the payload compartment. These were clear signs that something was wrong before Starship left Super Heavy behind. If you're still wondering why oxygen leaks are so dangerous, consider this. A leak near the engine firewall is one of the worst possible failures in a rocket. Oxygen is essential for combustion. The engines combine it with methane to generate the thrust that propels Starship into space. But there should never be excess oxygen in unintended areas. When it seeps into the wrong places, disaster becomes inevitable. That's not the only concern. Inside Starship, extreme heat, immense pressure, and intricate machinery all interact. Excess oxygen can fuel an uncontrolled fire, leading to overheating or even an explosion. In this case, the leak caused a dangerous pressure buildup that overwhelmed the system, culminating in a massive explosion. However, The truth is that oxygen alone is insufficient to cause the explosion we witnessed. After the Starship boom, the other culprit was the Flight Termination System, FTS. The FTS activated when it became clear that Starship was no longer stable. A flight termination system is a safety measure built into all rockets. Here's how it works. If a vehicle goes off course or suffers significant damage, the FTS triggers an explosion to prevent it from causing harm. However, many may not understand that the failure of Ship 33 also comes with some benefits. SpaceX doesn't just launch rockets. SpaceX treats every flight as a learning opportunity, with each failure providing valuable insights, and Flight 7 was no exception. One important takeaway is that upgrading Starship alone isn't sufficient. Some experts suggest that design modifications may have contributed to the explosion, as this version of Starship had structural differences from earlier models, which could have played a role in the failure. Another crucial lesson involves improving pressure management in critical areas. Rocket experts point out that the venting system was intended to control pressure buildup but proved inadequate. To prevent similar issues in future missions, SpaceX will likely need to redesign certain components. This brings us to another important aspect. What happens next? Keep watching to find the answer and more impacts of the Starship 33 explosion. Whenever there is a significant incident like this, an investigation follows. In this case, the Federal Aviation Administration (FAA) is now involved. The FAA oversees commercial spaceflight and ensures that every company follows safety regulations. Until the investigation is complete and SpaceX provides solutions, they won't be able to launch another Starship. Remember, this isn't the first time the FAA has stepped in after a Starship failure. Flight 6 ended in an explosion, and SpaceX had to work through 63 corrective actions before getting approval to fly again. That took months, so we still don't know how many changes will be required this time. But one thing is certain, Flight 8 won't happen until these issues are fixed. Here's another important point. While the loss of Ship 33 is a setback, it doesn't spell trouble for the entire Starship program. SpaceX is known for its rapid iteration, learning from failures and improving swiftly. They are already developing the next prototypes, Ship 34 and Booster 15, likely incorporating fixes based on the issues from Flight 7. The objective remains unchanged, achieving full reusability for Starship. This means both the booster and upper stage must return safely, refuel, and launch again, an essential step not only for cost reduction, but also for advancing deep space exploration. NASA, private companies, and future Mars colonization plans depend on Starship. It is not enough to speculate about future fixes to prevent another crash. It is also essential to mention the recent fixes that might have contributed to the current crash. Before Starship 33 ever left the ground, a lot had already happened. The flight was supposed to push SpaceX closer to making Starship fully reusable. Every detail leading up to the launch was carefully planned, from the rocket's upgrades to the countdown sequence. However, even the best-laid plans don't always go smoothly. How did we reach that moment? Let's rewind to the months leading up to liftoff and break down everything that made Flight 7 possible. We'll uncover the brilliant engineering behind the ship's design. You won't want to miss a single detail. Starship is a two-stage system. The upper section is Starship, while the lower is the Super Heavy booster. For Flight 7, these components were Ship 33 and Booster 10, both constructed at Starbase, SpaceX's private launch facility in Boca Chica, Texas. This is where innovation comes to life. Large steel rings are stacked like Legos, welded together, and equipped with engines, with each version designed to surpass the previous one. Ship 33 stood out as one of the most advanced Starship SpaceX had ever built, featuring a reinforced structure, an upgraded heat shield, and refinements to its 6 Raptor engines. Elon Musk pushed for a stronger, more capable ship than its predecessors, ensuring continuous improvements with each iteration. SpaceX engineers also did a great job with Booster 10. Its 33 powerful Raptor engines made it the most powerful rocket booster in history. The upgrades focused on improving efficiency, reducing vibration, and ensuring a more reliable system. SpaceX's Flight 7 had all the elements for a groundbreaking test, with the potential for a smooth landing after separation while both stages remain stacked. However, having a rocket ready doesn't guarantee an immediate launch. Before SpaceX could ignite the engines, they needed approval from the Federal Aviation Administration, FAA. Following the explosion of Flight 6, the FAA required 63 modifications, leading to months of delays as SpaceX implemented the necessary safety improvements. Some adjustments were minor software updates, while others were more significant, such as enhancing the booster separation system and refining the flight termination mechanism. The FAA insisted that Elon Musk ensure the rocket could be instantly destroyed if necessary. After months of discussions and modifications, the FAA finally granted approval, paving the way for the launch. Then came one of the most breathtaking moments at Starbase. SpaceX stacked Starship on top of Super Heavy at the orbital launch mount. The orbital launch is a massive steel platform that holds the rocket in place before liftoff. A giant robotic arm called the chopsticks lifts Starship into the air and carefully places it onto the booster. It is a highly delicate process, where everything has to line up perfectly. If something is off by even a fraction of an inch, it could cause problems later. After stacking, the entire rocket stood nearly 400 feet tall, for comparison, taller than the Statue of Liberty. With Starship in place, engineers ran a series of final tests, including cryogenic loading tests, where the tanks were filled with super-cold liquid oxygen and methane to check for leaks. A wet dress rehearsal, where the complete countdown sequence was run without actually launching, and an engine test to fire individual Raptors and ensure they worked properly. By that time, everything was in place. SpaceX had set a launch date, and the countdown was underway. Launch day began early, with teams at Starbase conducting final inspections before dawn. Every component, electronics, fuel lines, hydraulics, and sensors, underwent rigorous triple checks. Even the slightest anomaly could result in a launch scrub. The level of precision required was astounding. 2 hours before liftoff, all non-essential personnel were cleared from the launch pad. An hour later, fueling commenced, loading the rocket with over 10 million pounds of liquid oxygen and methane. At the T-10-minute mark, the final go/no-go poll was conducted, and SpaceX gave the green light. Then, the defining moment arrived. The final countdown began. 3, 2, 1. The engines roared to life. If you've ever witnessed a Starship launch, you understand its sheer power. When all 33 Raptor engines ignite simultaneously, they unleash an immense force that turns night into day, with a sound so intense it can rattle windows miles away. This launch was the most powerful one yet. Super Heavy fired up its engines, and Starship slowly lifted off the pad. The entire structure shook, but everything held together. The rocket gained speed, cutting through the thickest parts of the atmosphere. As Starship climbed, it reached max Q, the moment when aerodynamic stress was at its highest. The rocket passed this point without any issues, proving the strength of its design. Then came the critical part: booster separation. This is where things get tricky. Starship had to flip itself around, fire its engines, and separate cleanly from Super Heavy. Any mistake could cause both parts to tumble out of control. But it worked. The booster detached, and Starship kept climbing toward space. Meanwhile, Super Heavy began its descent back for landing. So far, so good. Starship 33 ascended beyond the Kármán line, the 62-mile boundary marking the edge of space. As the sky darkened and Earth's curvature came into view, its Raptor engines kept firing, propelling it to a record-breaking altitude of 91 miles, the highest a Starship had ever reached. It was also traveling at unprecedented speeds. But then disaster struck. The rest, as they say, is history. Now, we reveal another interesting part of the mission that achieved partial success, but has received little attention: Super Heavy booster's flawless catch. SpaceX engineers had been working toward a solution to bring the Super Heavy booster back down and catch it with Mechazilla chopsticks. They had already done it last October, something no other rocket company had ever attempted. Normally, boosters crash into the ocean, land on a drone ship, or touch solid ground. But SpaceX had a different plan. They wanted to catch the biggest and most powerful rocket booster in history right out of the sky. And now, for the first time, they were about to pull it off. Before the booster could even begin its descent, it first had to perform one of the most challenging maneuvers in flight: hot staging, a technique rarely used in space exploration. Instead of completely shutting down the booster's engines before separation, SpaceX opted to ignite the second stage's engines while still attached to the booster. This meant firing Starship's powerful Raptors directly above Super Heavy, akin to lighting a torch beneath a fuel tank and hoping for the best. Why take such a risk? SpaceX believes hot staging enhances separation efficiency. Normally, rockets waste valuable time and fuel coasting between booster shutdown and second stage ignition. By igniting Starship's engines while the booster was still providing thrust, they could gain extra velocity, conserving fuel for Starship's primary mission: reaching orbit and returning safely. When the critical moment arrived, Super Heavy's engines throttled down slightly. A split second later, Starship's upper stage roared to life, propelling it skyward. The flames traveled downward through a specially designed open ring near the top of the booster. The separation was brutal. Intense forces shook both stages, and heat from the firing engines slammed into Super Heavy structure. But the great news is that it worked. Starship shot off toward space, climbing higher and higher while the booster descended back to Earth. The most dangerous part was over at that point, but the real challenge was just beginning for Super Heavy. Keep watching, because things will get much more enjoyable. When Starship was gone, Super Heavy had one job: flip itself around and head back home. Although SpaceX already pulled it off in October 2024 for the first time in history, that wasn't as easy as it seemed. At this point, the booster was still screaming through the sky at thousands of miles per hour. It needed to slow down fast. To do that, it performed a controlled flip, turning its engines toward the Earth. This move was critical. If the booster lost control, it would tumble chaotically and burn in the atmosphere. Super Heavy's Raptors fired again, not to push it forward, but to slow it down. These boost-back burns helped adjust its path, guiding it toward the landing zone near the launch tower. As the booster descended, the atmosphere began to assist in slowing it down. Air resistance struck forcefully, shedding speed rapidly. However, this wasn't a smooth descent. The booster was a towering 230-foot metal structure, hurtling at extreme velocities. Even the slightest imbalance could send it into an uncontrollable spin. That's where the grid fins played a crucial role. SpaceX installed 4 large grid fins near the top of the booster, metallic flaps resembling waffle irons. These fins provided precise steering, making small adjustments to maintain stability and ensure proper alignment. While most rockets rely on small thrusters or built-in wings for control, SpaceX had refined the use of grid fins to perfection. They enabled the booster to shift left or right with real-time corrections, adjusting its angle to align precisely with the landing zone. As Super Heavy continued its descent, the grid fins worked relentlessly to keep it on course. The winds at this altitude were unpredictable, constantly trying to push the booster off course. However, SpaceX's precise algorithms kept the fins in place. Then came the final stretch. The booster fired up its engines one last time at just the right moment. This final burn wasn't just about slowing down, it was for precision purposes. The booster had to hover just long enough for the giant chopsticks on the launch tower to close around it. This was the part that had never been done before. Normally, rockets land on solid ground or a drone ship, where they have some room for error. But here, SpaceX was trying to place a massive falling booster between 2 robotic arms with barely any room to spare. The engines thundered, making real-time adjustments to keep the booster stable. Below, the chopsticks began shifting into position, ready to catch the rocket at just the right moment. The tension was intense. Any slight deviation could send the booster crashing into the tower, while an early engine shutdown would mean a disastrous free fall. Carefully, Super Heavy aligned itself. The chopsticks closed in, and for only the second time in history, the massive rocket booster was caught midair. The maneuver was executed flawlessly. However, the upper stage, Starship 33, was lost in an explosion. While the launch was only a partial success, it raises a crucial question. How will SpaceX bounce back from the loss of Starship? Fortunately, Elon Musk has a solid recovery plan. Stay tuned for all the details as we explore how SpaceX is pushing forward, undeterred by setbacks, with engineers already hard at work analyzing the data. Setbacks are part of progress, especially when working in an industry like space travel. The focus now shifts to what comes next. Fixing the oxygen leak issue is a priority. Another way to improve venting and pressure control systems is by improving them. But beyond that, SpaceX still has a long list of tests to complete before Starship can be considered fully operational. The company had one rule regarding setbacks: learn fast, fix fast, and fly again. That had always been the philosophy. If a rocket exploded, it wasn't seen as a disaster. It was data, and data meant progress. This was the mindset driving the push toward Flight 8. The investigation into what went wrong had given SpaceX a list of possible fixes, and now engineers were racing against the clock to get the next Starship ready. According to company sources, they will learn from the explosion and improve the design. So, we expect a tougher, smarter vehicle and are prepared for even bigger tests. At most aerospace companies, a rocket failure leads to years of delays. Engineers often conduct countless reviews, repeatedly verifying every change, causing launches to be delayed indefinitely. SpaceX takes a different approach. Rather than spending years perfecting designs on paper, they launch, observe the results, and refine based on real-world data. This strategy proved successful with Falcon 9. Early versions of the rocket experienced multiple failures, but each setback provided valuable data, leading to improvements and subsequent relaunches. Today, Falcon 9 stands as the world's most reliable rocket. With Starship, SpaceX continues to push the limits of space exploration. Moreover, media reports indicate that SpaceX aims for Starship to successfully complete reentry. Previous flights either exploded or failed before reaching this stage. But Flight 8 is specifically designed to demonstrate that the heat shield can endure the intense conditions of reentry. This will be no easy feat. SpaceX may need to test a more robust heat shield, refine the vehicle's descent control, and ensure a successful ocean landing as planned. If this works, it would be a huge step forward. This means that Starship couldn't just reach space and achieve Elon Musk's dream of rocket reusability and environmental sustainability. While preparing for Flight 8, rumors began to spread that Flight 9 was already in production. Suppose it shows us anything. SpaceX is not waiting for one launch to succeed before building the next. They are moving ahead as if Flight 8 had already worked. There is not much info at this time, but the job of Flight 9 would be to take everything learned from the previous flights and go even further. If Flight 8 successfully survives reentry, Flight 9 would take the next step, testing in-orbit refueling. Refueling in space is a critical piece of Starship's long-term plan. Without it, missions to the Moon or Mars wouldn't be possible. A fully fueled Starship could launch from Earth, but it wouldn't have enough propellant to reach its final destination. That's why SpaceX needs to develop the capability to send another Starship into orbit, transfer fuel, and provide the first one with enough power to continue its journey. Experts in space exploration believe that Flight 9 will test a preliminary version of this system. While it won't involve full refueling just yet, it will demonstrate the ability of two starships to dock in space, an essential first step. Successfully achieving this would be a groundbreaking achievement. No other company has ever attempted large-scale orbital refueling, and if SpaceX succeeds, it would gain a significant lead over the competition. With each flight, Starship continues to evolve. Let's take a quick look back. Remember the early test vehicles? They were rough prototypes, rapidly built to validate basic concepts.